Hello, welcome back. I was doing some more FP2 papers and I came across a very disgustingly beautiful question on series. I put the last question on the paper. It's a 4.5 star question, and as you probably know, for those who do read my notes on my website, a lot of the emails that I'm getting, it seems that many of you don't, and you're asking sometimes for the obvious. The papers U, V, W, X, Y, Z are they have a little bit of a punch compared to the papers A to R, while the S and T are purely enrichment material for most of these ranges of papers. So this is actually not on the super hard papers, but they are on the hard papers. So this particular question on series says the following. I'll try to abbreviate it because, of course, I'm going to need quite a bit of space for this particular question. It says a function f of r is defined as 6r to the 4 plus 6r cubed minus ar squared minus ar plus 1. The whole thing is over r plus 1. And later on, where a is some non-zero constant, blah, 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 blah. And it says if the sum of the f of r's from r is equal to 1 to n is equal to, what is it equal to? Now, let me just put the FP2W because I don't remember the question. It's the last question on the paper. Yeah, it is equal to n squared, n plus 2, 2n plus 1 over n plus 1 to find the value of a. This is an unusual question. I remember I wrote it probably a couple of years ago, and straight up away when I was doing my planning, I did put it on paper W. So obviously it's been sitting there for quite a while as part of this paper, but today I formatted the paper, so it's you're going to be seeing this question and solution, of course, real soon. So what do we start with this? This is actually vile at first glance, and it almost makes it to a 5-star question. It has no structure. So this is our f of r, this is the sum, and this is what it sums to, the first n terms. This is quite interesting, and I think this is where we need to start with this. So f of r, first of all, I spot r to the 4r cubed. Factorizing will give me things like that. And again, this minus ir squared, there's some kind of patterns in there, factorizing in pairs kind of thing. So let's go for this approach first of all. So I can pull out the 6r cubed out of these two terms, r plus 1, and pull a negative ar, r plus 1, plus the 1 that was already there, over r plus 1. And do a little bit of cancellation. Oops, we lost the r plus 1 there. This term here, we can lose from the r cubed and r squared. This will go completely. I'm not putting, of course, all the extra workings. Actually, this does not need to go up there because there's no fraction left. 6r squared. This bit here, r cancels, r plus 1 cancels, so it's minus a plus 1 over r plus 1. That looks a little bit neater. And if I sum this f of r, I have standard result for that. That's the sum of squares. Standard result for that. That's the sum of ones, basically. And a, what I will sum up to. I'm going to write in a minute. How do we sum this? Well, this is partial fractions of some sort. So this mixes standard results and method of differences. I'm going to do this partial fractions. Of course, you can take as many lines as you want. This is for those who do partial fractions all the time. This is the bigger one. That's going to be the minus. And I'm doing about cover up here, but it's not even a cover up. It's kind of experience. So that's just checking it, obviously, always. R minus R cancel, and then 1 on the top. So that's correct. So my f of r is this. And at the same time, okay, now my sum from r is equal to 1 to n of f of r. Of course, this is given here. Maybe I should write it. Let me just use a different color pen so we don't mix things. This is a given. Well, this is the sum of f of r. That is going to be the sum from r is equal to 1 to n, 6r squared minus a plus 1 over r minus 1 over r plus 1. Okay, let's make a bit of space. So we don't really, I'm going to leave that bit there because that was given to us. This is the manipulations that I've done to get my f of r into this bit here. And I should really put a bracket in there. So let's put a bracket to keep it warm. All right. Where do we go from there now? We begin the summation. Or actually, I'm gonna need a lot of space, so let's move this right-hand side to the left of my board. The sum, of course, we can split that into individually 4 items. Now we're on 4.5, so I'm not going to be showing next step sigma of that, minus sigma of that, plus sigma of that, etc. So sum of r squared, so that's 6. From most formula booklets, this sums to 1/6, the first n terms, n, 2n plus 1, n plus 1. So that is just this bit here, minus an. That's basically a1 from r is equal to 1 to n, which of course is a 1 plus 1 plus 1 dot 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 dot. You're adding n of them. So it's going to be, of course, a, which is at the front, times n, which is an. That is that bit there. And normally I do really write this as a table, and normally if in my solution I probably will write it as a little table and separate because it's easier to see. But here, because I'm pressed for, I have to keep rubbing and I'm under an awful lot of space, I'm going to actually write this separately. So these two bits together, when I put r is equal to 1, it's going to be 1 minus a half. When I put r is equal to 2, I'm going to get a half minus a third. When I put r is equal to 3, I'm going to get a third minus a quarter. Plus dot dot dot. When I put r is equal to n, I'm going to get 1 over n and minus 1 over n plus 1. How did that change from black pen to brown pen all of a sudden? Wow, it's when I actually wrote this result in there. Okay, I'm gonna go back into my black pen. So this cancels, and let's start looking at this bit as well. Half, third, the minus a quarter, of course, will cancel the plus quarter, and this plus would have cancelled with the previous term, so I will also lose this bit here. So this have all gone, so that would be 1 minus 1 over n. So let's start tidying these things up. 2n squared. So we have now 2n squared. Let's write it as 2n cubed. Plus 2n, plus 2n plus n is plus 3n squared because of the n on the other side. Plus 1, it's just simply plus n. Minus the an, which is there. And then we have a plus 1 minus 1 over n plus 1. So that is a little bit of a pain now with all of this because we have a denominator here, but we have, of course, a denominator, the n plus 1 appeared in there. So first of all, let's write this as 2n cubed plus 3n squared plus n, plus n, factorize it, 1 minus a from these two terms, plus the 1 minus 1 over n plus 1. So that is the right-hand side now, all of this bit here. And again, I'm going to put into the common denominator. And I'm going to write it as n plus 1 multiplying all of this, 2n cubed plus 3n squared plus n bracket 1 minus a plus the 1 which is there. And then, of course, this doesn't need anything, minus a 1 over n, oops, wait a second, plus 1 minus, so that's the n plus 1 to multiply all of this. See, I'm making mistakes. I'm completely out of practice. I'm not very well sometimes, and my medication is causing all sorts of problems. So I do apologize, and I apologize for my cough as well. So this is how far we have gone so far. And now we can compare, if you want, this quantity with this quantity. That, of course, will give us the a. And, of course, we have the same denominator. So we only need to compare this numerator with this numerator, which, of course, there is an a in there which will allow us to find the value of it. So we make a bit of space. I think we should, because I don't think we can fit this question. How many marks is this question? How many marks did I give? This is a 12 marker. It's the last question on the paper, and there's a total of, oh, sorry, I moved the thing. Let me have a quick look if we're still in. When we're recording, you can see what I'm doing. We can. Yeah, it's the last question. It's question 8. So quite a difficult question. It involves both summation of series by standard results as well as the method of differences. So first of all, I'm going to tidy this up because I want to expand that, and I'm going to expand that. This is not too difficult to expand. Let's go brown for this. So we got 2n squared, 2n cubed. Just the numerator. We have a 4n, 5n, 5n squared. And then we got a plus 2n, sorry, what have I done? I've done something wrong? No. 2n squared, sorry, is to n to the 4. And then we got, of course, that 5n squared is 5n cubed. And lastly, the 2 is 2n squared. So we'll be comparing essentially this line now, which is what we got up there, but in expanded form, nothing more really. And let's see what this thing gives us that we got right at the bottom. So quite long to expand that. So it's n times that, n is 1 times that, minus the 1 at the very end. So let's, I'm going to stagger the terms as you will see. So we're going to have 2n to the 4. I'm doing the n times that, plus 3n cubed. Plus 3n cubed. Now, when we reach that, it's n times that. So the n, it makes that into an n squared. So it's going to be a plus n squared. But he also makes an an, negative an squared. I'm going to write this underneath it. So I have minus an squared plus n. So that's the n term. So I've just done so far the n times this square bracket. And then I've got 1 times the square bracket. So it's merely copying it. 2n cubed, 2n cubed. It looks quite good at the moment because that's the 5n cubed. There's the 2n to the 4. So we got 3n squared plus 3n squared. Then I have 1 times that, which I will expand. So it's going to be an n plus n minus an. That's from that bit there. Plus a 1. And of course, I have a minus 1. I could put it here, but I want to put it there and cross it out. So what have we got so far? We got 2n to the 4, which gives us no real information about the a, but at least it's telling us we're in good shape because we have got these 2 terms correct up there. So we need to see now how many n squares we have in there. We have 3 plus 1, 4, minus a, 4 minus a, n squared. And the n's are going to be 1, 2, minus a. So 2 minus a, lots of n. If you cannot see that, take your time, multiply out afterwards. So that's the 4n squared there. And there's the an squared with a minus there. And the same thing, 2n, that's the 2n there. minus an. So now this particular quantity must match, these two are identical, and the n squared term and the n term should really give us the answer, and the must of course give us the same a, otherwise there's inconsistencies, impossibility in the question. So what do we have? We have from this one here, there's no n term there, so this bit must be 0, so evidently a must be 2, and if we check this one just to see, it does give us the right thing. 4 minus 2 is in fact 2, so a in this particular question is 2. How many are going to manage this question? I have no idea, but in my opinion it's a very beautiful question, and I couldn't help but do a video on it the moment I saw it on my paper. For the time being, I'm signing out, and I'll see you real soon. Bye for now.